Welcome to today's video where we're going to begin our next unit on absolute value functions, equations, and inequations. We're going to start with quadratic inequalities. So there's a few kind of prerequisite skills we just got to make sure that you're familiar with. So the first one would be make sure we're able to solve a linear inequation. So something like this. If I was to take this and solve for x, it's basically solved the same as an equation with one small exception which we'll put in play here. So I'm going to move all the x's to one side. So 2x subtract 6x is greater than 7 plus 5. So negative 4x is greater than 12. To get x by itself, I'd have to divide by negative 4. Divide by negative 4. This is the one thing I was mentioning earlier, that you have to make sure that this, if you divide by a negative or multiply by a negative, you must reverse your inequality. So this is going to go to, which will give us x is less than negative 3. Looking at a graph, let's suppose this was some function f of x, and I was trying to use this graph to determine the answers to each of the following. Well, the first one says, where is f of x? This is the graph of f of x. Now on a graph, this is typically your x-axis, and this would be your y-axis. Well, y could be interchanged to mean the same thing as f of x. So this is your f of x axis, and this is your x-axis. So this is asking me, where are the y values greater than 0? Well, on a graph, the y values are greater than 0 if they're above, and if they're below, your y values are negative. So in this situation, it's asking me to identify where this function is positive on the y-scale. There's one spot, and then there's another spot over here. What it's asking me to identify are what are the x values that would give me those particular segments of the graph. Well, if you look carefully, this would be any x value between negative 2 and positive 1. So negative 2 is less than x, which is less than 1. Notice I didn't put the equal signs because at negative 2 and 1, it's not greater than 0, it's equal to 0. And then again, here, which would be any x value you pick that's to the right of 4, you would also get positive values up there. So, or any x value that's greater than 4. Now looking at this graph, and I said, well, where is this function less than or equal to 0? Well, there's two loops again, so there's another one down here, right? That's less than 0 down there, and then there's another one over here. So I need to describe those sets of numbers. So it's anything less than negative 2, or the other one would be anything between positive 1 and 4. So if 1 were less than x, we're less than 4. Then this graph, oh, I didn't notice this. There's an equal sign on this one. So this time it can equal 0, so I'll put the equal signs on here. All right, so those are kind of what I call prerequisites, things that we should be able to pick out and identify from prior knowledge of mathematics that will lead us into this current section, which is solving what are called quadratic inequalities. Now, we're going to have to use some of the things we've learned earlier on in the course. Let's take this one for example. I'm going to show you two strategies. So I'm going to show you strategy 1, which is my preferred method, which is by graphing, or a sketch, I guess. I find this the easiest. Okay, the way this works is you take your quadratic and you treat it rather than an inequation, so move everything to one side like you would an equation, and rather than greater than or equal to, well, let's go to this first. So greater than or equal to 0. Then you're going to find the zeros. So to find the zeros, we need to find the zeros, which is fancy lingo for x-intercepts. So the x-intercepts are found by taking 3x squared, take away 13x plus 10, and make it equal to 0. Don't use your inequality. hard trinomial, so try and factor it. 3 times 10 is 30, and you need to get a minus 13. So let's go negative 15. No, I need to get plus 30. So it has to be minus 10. 3x subtract 10, and 3x subtract 3. Negative 10 times negative 3, right? Hard trinomial. So that's plus 30, and you need to add to give a minus 13. There's your minus 10 and your minus 3 equals 0. So x could be 10 over 3, or, oh, I forgot to divide this one by 3. Let me erase a line here. All right, so we divide these by 3, so this one doesn't reduce any further. This one is x minus 1 equals 0. So that gives me x. If you solve this one, it would be 10 over 3. And if you solve this one, it would be positive 1. So those are what we call the zeros. So to solve this inequation, this is all we do. We draw a number line, put these two numbers relative to where they would fall in a number line. So 10 over 3 is 3 point something, so that should be to the right of the number 1. So the number 1 would be here, and the number 10 over 3 would be here. You look at the stretch factor, which is this, which means it opens up, and it's a quadratic, so we know the shape of these from our study in Unit 1. It has to open up. The good news is it makes no difference where you put the vertex. So I'm not going to go and find the vertex. I don't need to know it. You'll see why in a moment. Now what I'm looking for is where would this quadratic, 3x squared, which is what I just drew here, roughly, where would it be greater than or equal to 0? Well, greater than or equal to 0 translates into positive. So basically, where is this quadratic positive? Well, it's positive if it's above, it's negative if it's below. So it's above here and here. So therefore, any x value you pick over here, you're going to get positive values on the quadratic, or any x value you pick over here. If you pick something in here, you hit the graph down here, which are negatives. That's not what I want. I want it to be bigger than or equal to 0. So the interval would be x is less than or equal to 1. Now I'm going to include 1 because it said it could equal 0. Or the x value could be greater than or equal to 10 over 3. And that's it. So any x value you pick in these intervals, if you were to fill them into this original inequality, it would make for a true statement. Now, strategy 2, I'm going to show you, just because we are going to use this strategy later on when we deal with absolute value equation. So strategy number 2 is done using what is called case analysis. And I'll show you how this one works. And I think you're probably going to agree it's a little bit more work than what we just did, so we'll probably not use it very often until later on when we have to. But this is a good spot to see how it works. So case analysis works this way. You do the exact, you get it set equal to 0, blah, blah, blah. You get down to here, so 3x minus 10, right, this line right here, onto x minus 1, and now you put your symbol back in. So it's now greater than or equal to 0. And case analysis is done using this rationale. I have two brackets that are being multiplied together, and I want the answer to come out to be greater than or equal to 0, which means positive or 0. So the only way to multiply two things together and the answer be positive is if you multiply a positive by a positive, or you could multiply a negative by a negative. That would also give you a positive. So what we do is we do a case analysis. We say, well, case 1, maybe the first bracket, 3x minus 10, is positive. Because there's equal to 0, we'd also put equal 0. And the second bracket, x minus 1, is also bigger than or equal to 0. So then you just figure out, well, what x values will make this happen? Well, 3x would have to be bigger than or equal to 10. X would have to be bigger than or equal to 10/3. X would have to be bigger than or equal to 1. So you're going to try and find out numbers that work here and here. So on a number line, 1 is here, 10/3 is here. Anything bigger than or equal to 1 would be any number to the right of and including 1. Bigger than or equal to 10/3 would be any number to the right of, and including 10/3. Where both were true, you're looking for where did the two graphs overlap. These two graphs overlapped if x was bigger than or equal to 10/3. There's one set of solutions for this. Now we do case 2. Case 2, so this one was the positive times positive. Case 2 would be the situation where maybe each of the two brackets gave you negative answers, and then if you multiplied two negatives together, that would also give you a positive. So case 2 is 3x subtract 10 is less than or equal to 0, and x minus 1 is also less than or equal to 0. 3x is less than or equal to 10. X would have to be less than or equal to 10/3. This one would be x is less than or equal to 1. So here's 1. Here's 10/3. Less than or equal to 10/3. It's all those numbers. Less than or equal to 1. It's all those numbers. Those were the numbers that were true for both. Those are any x value that is less than or equal to 1. So this could have happened, or this could have happened. So when you write out your answer, you say, well, x could have been bigger than or equal to 10/3, or x could have been less than or equal to 1. And that would be what we call our solution set for this set of numbers. So if I look, here, when we did it the other way, we got x is less than or equal to 1, or x is greater than or equal to 10/3. If we look at case analysis, of course, we get the same answer. X is bigger than or equal to 10/3, or x is less than or equal to 1. So this is using what's called case analysis, and this would be using a sketch. You would never be asked to do it any particular way. You get to choose whichever way you're more comfortable with and solve the inequality using your strategy of your choice. But you definitely need to be able to solve a quadratic inequality. Let's look at a couple more just to make sure you're okay with this. So it says here, use only one strategy, your choice. All right, x squared minus 4x minus 10 is greater than 0. Well, we need the zeros, so I'm going to do it with sketching. And this one's really more susceptible for sketching. You'll see why in a sec. The problem here is it doesn't factor. So if it doesn't factor, for me to get, I need the zeros, or the x-intercepts. Well, to get those, I need to set this equal to 0. So x squared, take away 4x, take away 10, equals 0. And it won't factor, which doesn't mean the world is ending. It means we just have to do a different strategy. Factoring is one strategy in a list of ones that we've been given. So I'm going to have to go quadratic formula. So x would equal negative b plus or minus b squared, subtract 4, multiplied by a, multiplied by c, over twice the a value. So x comes out to be 4 plus or minus, this would be 56 over 2. So that's 4 plus the square root of 56 over 2, or 4 subtract the square root of 56 over 2. You could get actual numbers here if you'd like. Let's grab a calculator. So I'd have 4 plus square root 56, and then divide that by 2, 5.742. 5.742. 4 subtract square root of 56. Divide that by 2, I get negative 1.742. Negative 1.74. So it doesn't make any difference whether these are nice integer numbers like they were in the last one, or rationals, or they're irrational like this. You still do it the same way, which is what I like about the sketching method. Go to your number line, put these where they would be, so negative 1.742. 5.742 would be to the right of that. This quadratic has a positive stretch factor like the last one, so it opens up as well, like so. We are looking for where it is greater than 0, which implies above the x-axis. No equal sign this time. So above the x-axis would be here and here. So we need to identify x could be less than, no equal sign this time, negative 1.742, or the x values could be bigger than 5.742. And those would be the solutions to this quadratic inequality. So, yes, the quadratic formula may be called upon if it doesn't factor. Sometimes they do, sometimes they don't. Let's do one more maybe, I'll throw some negatives into it. So I'll just make a new one here. Let's suppose we have the quadratic negative 3x squared plus x is less than 4. All right, so I'm going to move everything this way. Negative 3x squared plus x minus 4 less than or equal to 0. I'm going to recommend you do this. Always work with positive stretch factors. You say, well, how can I do that? It's very simple. Just take this left side and multiply everything by negative 1, which means you also have to multiply the right side by negative 1, which is fine. This will switch to 3x squared. This will now go to minus x. Oops, I got these backwards. This should be minus 4. Sorry, this won't work. Where's my black pen? Make that a minus 4. And then make it a plus 4 here. And then this will switch to a minus 4. But here's the one thing you got to watch for. If you're going to switch the sign of all these by multiplying by a negative, you must reverse the inequality. So now it goes to greater than or equal to 0. Just for the sake of, because we're going to get the same type of region again. Let's just bear with me and switch this to the other way. Let's say it was, oops, well, whatever. Let's say it was greater than or equal to. So this was greater than or equal to. So then when you get to here, it's going to switch so that we have to do a less than or equal to. So this should switch now, and let's say it's less than or equal to. Okay, so I've set this one up so it will factor, which it will. 3 times negative 4 is negative 12. Hard trinomial, I want to get negative 1 in the middle, so I'd go negative 4 plus 3. Remember, I'm finding the zeros, so I'm just going to go equal 0 here for a moment. Divide by 3, divide by 3. 3x take away 4, x plus 1 equals 0. So x could be 4/3 or x could be negative 1 would be my zeros. Over here to your number line, negative 1 would be here, 4/3 would be here. I've adjusted it, so be careful now. Don't look at the original. We've adjusted it to this one. So because it's this one, now the zeros would be the same here, and you could use this one, but the difference would be you'd have to make it open down instead of up, and it would be greater than instead of less than. I'm going to go with this version, the opening up version, like so. And I'm looking for, this time, where it's less than or equal to 0. Well, less than or equal to 0 means negative, which is this loop down here on the bottom. That's where the quadratic is negative. So that would happen between negative 1 and 4/3. Now make sure you can write this out properly. Negative 1 is less than, there is an equal sign, or equal to x, which is less than or equal to 4/3. That means every x value between negative 1 and 4/3, if you were to plug it into the original quadratic, you would get negative values for your quadratic. And that is how you solve quadratic inequalities. Now you may say I'm going quite quickly, but keep in mind we've done a unit on quadratics, so I'm breezing through this stuff under the assumption you are comfortable with the material. Hopefully you are, and if nothing else, it's forcing you to go and revisit your knowledge of quadratics. All right, thanks for watching. If you have any questions, reach out. There'll be some practice questions in your class notebook that you can use to make sure you're comfortable with the material. Thank you.